Hi everybody, it's Mr. Matthew here to talk about variation in populations. So obviously it's going to tie into our understanding of the concept of evolution because variation is a key component of natural selection. Let's get to it. So first up, I want to explain how genetic diversity of a species or population affects its ability to withstand environmental pressures. So we see here over on the left here that we've got this broad variation that exists in the initial parental generation up on the top. And that's represented by our normal distribution curve here along the top. And then what we find here is that by doing this, we have individuals that are enormously different in this given trait. And again, this is sort of a generic trait graph. I haven't given you a specific phenotype, but the general idea is you can imagine that there's going to be variation here. Now, most of the individuals have in this parental generation the trait at a magnitude of about 5. But some of them are smaller and some of them are larger. Now, if there is an environmental shift, an environmental selective pressure, where those with the smaller beaks cannot survive and reproduce, but those with the larger structures can survive and reproduce, then the ones that are able to survive and reproduce are going to be on average larger, and you're going to see a shift in the next generation because those that survive and reproduce are larger. Therefore, on average, the genes of the next generation will also be larger. And so what you see from the top to the bottom is generation 1 to the generation 2, how you see a shift in the average trait amongst the population from one generation to the next. So the reason for this is that by having variation, you have a wide amount of phenotypes, and therefore, depending on the selective pressure, maybe having larger characteristic is an advantage, maybe having a smaller characteristic is an advantage, maybe having both the extremes is an advantage. Whatever the environmental conditions, if there is variation, it is more likely that the population will have some members of the population that will be able to survive and reproduce in the face of an environmental change. So when we look at the level of variation of population and how that affects a population, we know that the population's ability to respond to a change in the environment is going to be influenced by its genetic diversity. As a general rule, large populations tend to have large amounts of genetic diversity. If you were to have a population decline dramatically and go through something where the population size was to get very, very small, a species becomes very, very endangered. Now, when that occurs, that species is going to then have a lot less genetic diversity, and they become at risk for extinction. We've seen that their genetic diversity has declined and they may or may not be able to recover. This is actually one of the major concerns that happens with species that get on the endangered list. The idea of targeting species that have become endangered or whose genetic diversity has dropped down is that we are concerned that they may drop down to the point where, yes, we are able to save and have a small number survive either in captivity or in very special environments. But if the genetic diversity doesn't recover, then in the wild, those species are going to be very susceptible to disease or any other sort of shift that would take place in the population. So genetically diverse species can handle it when the environment becomes perturbed because they're more likely to contain individuals that have variations that can withstand that environmental pressure. Again, sort of going back to our previous concept that if you have a lot of different types of individuals within a population, then depending on how things happen, you may have a very small group that possess a trait that is best for this new environment. That could be something like a resistance to an antibiotic or a resistance to a new novel disease. While many individuals within that population may be susceptible, if you have a great variation, you're more likely to have some who can survive that shift or that change. So one of the things that we can see is that alleles that are adaptive in one environment may not be adaptive in the other. In fact, may be deleterious in other environments. And so we have this classic example of the rock pocket mice. And this is an area down in the southwest of the United States where there are these dark lava flows. And these dark lava flows create these dark areas and then sort of light brown areas along the the ground. And we find in these areas that there are these different colorations of rock pocket mice that live either in the really dark regions or in the light brown regions. So this is a perfect example of these two species can actually be side by side. And if they were to move over just a matter of feet, this is a case where if you take these very dark colored mice and you put them just a few feet over onto that light brown soil, predators are going to very easily be able to see them and select against them. Conversely, if you take that light brown mouse and you put it in the dark lava flow, it's again going to be very visible to predators and will be selected against. So these two individuals, just by having their environments slightly next to each other, having variations in those two populations, you saw different selective pressures depending on whether on the dark lava flow or the lighter soil that's right next to it. Okay, so one could assume that the original population of rock pocket mice had variations in color. And even within those dark mice, we would see some light mice will appear, but those are not going to survive and reproduce as well. And similarly, in the area where there are light mice, every once in a while, there'll be a darker mouse that is going to be produced. But again, they will not survive and reproduce quite as well on that light environment, and therefore they'll be selected again. So strong selective pressure onto which mice survive best in which environments. All right, well, I hope that was a helpful review of variation, and I'll talk to everybody soon.